AP Calculus AB, area bounded by functions in terms of y. So took a really simple example and going to try to explain how you might do this, different ways you might do this. So we're supposed to find the area of the region bounded by y is equal to x, and then y is equal to 2 minus x, and y is equal to 0. So I have that graphed in here, and here's the shaded area. This is the area that I think we're looking for. And we know from calculus that the area is equal to the definite integral from a to b of f of x minus g of x dx. And then this is the top function, and this is the bottom function. But we look here, and we see that this thing switches. We see that what we have here is we have, on the intervals 0 to 1, we have y is equal to x over y is equal to 0. And then on the second interval, from here to here, we see that the pink function is now on top of the green one. So we could set that up as two intervals. And what I'm suggesting to you is this, that this is another way that you might do this. So what I'm going to do is this. If you don't mind, what I'm going to try to do, I wonder if I can actually do this with my hand. Let me see if I can do this. Grab this thing. Oh, of course not. I was just wondering if I could actually pick up the whole thing and spin it. But you get the idea. What I'm trying to do is I'm trying to pick this whole thing up and turn it. So I'm looking at this as if this was the x-axis and this as if it was the y-axis. So I'm putting these things in terms of y, because if you could look at it, I'm turning my head real weird. I'm looking at it like this is the base. So imagine you could spin this, and this piece right here is down here, and this green side is running like that. Then you'd see that y is equal to 2 minus x is on top for the whole interval, isn't it? So I'm going to set this up in this way. I know that this value right here is 1, right? So I'm going to look at it this way. I'm going to say that the area is equal to the definite integral from a to b of f of y minus g of y dy. Again, looking at it as if this thing was turned. So here's the green side, here's the white side, right? So I'm looking at it that way, and if I did it that way, then I could see that this is on the interval. That on the interval, let this be the interval from 0 to 1 this way. That this pink curve is on top the whole time. So I'm going to say that the area is equal to, and you can see that we're starting here, and we're going to go to there. So we're going from 0 to 1, from 0 to 1 of. Oh, I guess now what I have to do is this. I have to switch this around. I have to solve this for x. So if I solve this function in terms of x, just a little bit of algebra, you'll get x is equal to 2 minus y. Remember that the sign switched because that's a negative x there, so that's going to switch. Then this one, I don't have to do much at all. This is just if y is equal to x, then if I turn that around, then x would also be equal to y. So I'm going to set up my integral that way. So I'm going to get 2 minus y, right? Minus this negative sign is this one, and then you can see as we're looking at it this way, if this was the top and this was the bottom, if we look at this vertically, then this would be the bottom, so we get minus y, wouldn't we? And the whole thing, of course, instead of being dx, your reader's going to want to see this, that I put this in terms of dy. So dy, I'm going to go ahead and simplify this and say that the area is equal to the definite integral from 0 to 1 of 2 minus 2y, isn't it? 2y dy. I'm just cleaning that up, right? Negative, this turns into negative y, so I have 2 negative y's, so 2 negative y. From there, I'm just going to integrate. I'm going to go ahead and integrate this. And as we integrate this, I'm going to have to write this in correct integral form. This is going to be 2y minus y squared, right? Because we square this top, square the bottom, and negative 2 over 2 is negative 1, so that's where that went. As evaluated from 0 to 1. And we can do this as a single, on a single interval. When I take that, I'm going to take, remember that fundamental theorem of calculus is f of a minus f of b, so we're going to take f of 1 minus f of 0. Well, f of 1 is 2 times 1 minus 1 squared is 1 is equal to 1, right? Minus f of 0 is 0, so is equal to 1. All right. So remember, this is really going to come in handy, and I know that hopefully you can see this and you're like, yeah, I would just do this using geometry. But if you can actually imagine this as the y-axis and this as the x-axis, and just switch your variables, you can do this another way, and you can use this formula that you already know. All right, you guys, I hope this was helpful. I know this is a real pain, but you're going to get great at this, so keep it up. If you have any questions or comments, let me know. Thanks for watching. If you haven't subscribed, please subscribe. Thanks.